So hello and welcome everybody to another episode of Lab Automation 101. I did want to start off by saying thank you to everybody who's downloaded and supported the podcast. It is very humbling and I'm very grateful, very thankful for all your support. I'm absolutely delighted today to kick off, season 2 of the Lab Automation 101 with a guest. Actually, it's our second guest from sunny Manchester in the UK. We have with us today Saba Khan from the Team Laboratory Consultancy Group. I hope I said that correctly.
That's correct. Yeah, it's perfect. You got it first time around. Thank you, Alex.
It's quite a mouthful.
Yeah.
So Saba, maybe just to kick us off a little bit, if you want to just give us a brief background of, who you are, what you do, and I guess very importantly, what Team does as well.
Yeah, thank you. Thank you so much for having me, Alex. So I'll tell you a little bit about myself. So I'm a scientist. I've had sort of over 15 years of experience within laboratories and working in different organizations. So I did my degree in biomedical sciences at the University of Manchester. And then after that, I worked in a hospital lab. So I worked in a pathology lab in microbiology. And then from there, I worked in a university lab. So I worked at the University of Manchester for about 12, 15 years. And then sort of the beginning of the pandemic, which is kind of where I sort of really got really fascinated with COVID research. I was involved in setting up a clinical trial across 4 hospitals in Greater Manchester. And then I had some pretty cool experiences. So I traveled to Iceland, where I worked setting up a COVID testing laboratory for film production called Welcome to Earth, starring Will Smith. And so that was pretty cool. So I did that with the National Geographic and Disney. And then when I returned back from Iceland, I took a job with the Department of Health. So I worked for the government, where I was setting up COVID testing labs and sort of traveled up and down the country setting up labs. And as part of that, I came across, started working with automation. So we developed a fully automated COVID screening platform. And that's when I started working with lab automation, working with liquid handlers and working with scientists to help them implement that into their laboratories to help them with the COVID testing. And so that's actually kind of where I started thinking, well, actually, there's this huge gap between sort of science and engineering. And I realized, well, actually, it would be quite nice to help scientists to automate their manual processes. And this is kind of where the inspiration for the Tiger Team came from. And actually, the Tiger Team was it's actually a military term, and the government used it to actually, they described us as the Tiger Team. So we were part of an operational arm. So we would get deployed to laboratories that needed help if they had like contamination issues or they needed help with training scientists. So we were part of that team. So we would get deployed to a site for about 2 days, fix all the issues, and then go back. So that was the inspiration for the Tiger Team. So I decided I would set up my own company, and I've kept hold of the term Tiger Team because I quite like it.
Well, it is very cool, to be honest. It's a nice story. I like how you threw in, you did some testing for Will Smith also.
I know. Yeah.
Very Hollywood of you.
Yeah, I know. Yeah. I'm such a name dropper.
I was ready for a few more.
Well, it was amazing because I worked with all these cameramen and they actually got to work with Will Smith. But I was stuck in a lab in Reykjavik, so I didn't actually get to meet him. But yeah, I did test his saliva. So
testing Will Smith's saliva, excellent.
Yeah.
So, I mean, obviously, then you've talked about working in hospital labs. You worked at the University of Manchester, which is something we have obviously as well. Department of Health. You were in Iceland, and so on and so forth. So, I mean, you've obviously had plenty of contacts with scientists over the years.
Labs
and so forth. And so, I guess based on your observations, being in the lab, talking to scientists, and so forth. What do you think that they, and I use the term struggle, I was going to say, what do you think they struggle with most? But maybe I should change it and say, like, what do you think their biggest challenges are? If you were, and I know this is a fairly broad question, but if you were just to say like 2 or 3, and it's a twofold question. So what do they have the biggest challenges? What are their biggest challenges?
Yeah.
And with that, how does automation play its part in terms of helping to overcome maybe those challenges for them?
Yeah, so these are just like general challenges that a scientist would face in a lab, not specifically to lab
Yeah,
automation. Well, so I mean, one of the biggest challenges is when you first pick up a project. So you could be a master's student or a PhD student, or you could be postdocing. I think one of the biggest challenges is you're stepping into a field of research and you don't know what's been done before you. So I always think that's always quite difficult, is sort of going into a lab, and it's, even though you're very skilled and trained, it's sort of understanding what has been done before you. So understanding all the experiments and all the work that's been done before you to then know, how do you then go forward? Like, how are you then adding value? So I always think that's quite difficult when you first step into a laboratory. And then sort of learning the protocols. I think that's every lab that you go to will do a protocol slightly differently. So you can take
right.
like an ELISA or a PCR. Every lab, there will be a generic protocol, but every lab will have their own methodology.
Okay.
So it's not like, you know, in research, it's not like it's not as standardized as, say, if you're working in a hospital laboratory where it's more standardized across all hospitals. In research, it's very much like, this is the protocol that someone did 20 years ago, and we've kept hold of that protocol. So it's very lab specific. So I think that's always quite a challenge, is when you first go into a lab, first of all, understanding like sort of like the lab layout and just understanding what people before you have done, and to then understand how do you go forward, and how do you add value. And then second of all, just trying to figure out and understand and learn those protocols within that laboratory, because it won't be, you won't go in and know exactly, this is the protocol I need to do. You then have to learn from the other people in the laboratory, and you then have to go through all your you have to go through all these archived folders of existing protocols. So then picking up those protocols, and then I suppose this kind of feeds into a little bit into the automation, is then, well, if this is the way people have always done things, you might come in and you might say, well, actually, why do you spend hours doing that? I've come from another lab where they might have automated that process, or they might have a different way of doing that part of the process. So then I think that's quite difficult, is if you're new to a lab and you have your own ideas, and you might say, well, actually, you could do this so much more quicker, or why don't you buy that reagent in, rather than spending hours making your own agarose gels, for example. Why don't you just buy them in? So that, I think, can be quite difficult, because you're almost challenging, and it almost becomes like an institution, right? If you've had a lab and a professor that's been there for 20 years, and you come in and say, well, actually, why are you spending so long doing that? You could just buy it in. So I think that can be quite difficult if you're facing that kind of, not resistance to innovation, but it's almost, this is the way we've always done it.
Correct. But do you think then, if you were to go, based on your points then, but if you were to go into a lab that had automated solutions, you think it would be a little bit easier then to learn the protocols, to see how you can add value and so forth?
Well, I think the automation is probably a different set of challenges, because then you've got to then, if you don't already know how to run that liquid handler, or you don't already know the programs, and you're learning a whole new set of skills, right? So
Yeah.
that's like, it's different. But probably, yeah, labs that probably have automation are probably a little bit more open to innovation, because they probably would have put in terms of their grants, when they were trying to get the funding to bring in the automation, they probably had to apply for some kind of innovation grant anyway. So they were probably already thinking along those lines, compared to a lab that's always been completely manual.
Yeah. And so going back to your point then about, you had mentioned resistance to automation.
Yeah.
And I know we had spoken, in our pre-chat, we spoke about, or you had mentioned, at least particularly universities maybe in the UK seem to be the most resistant and so forth. So it's not to pick on the universities necessarily, but
No, it's
I guess
probably more the mindset. Yeah.
yeah, but as a general point, I guess, because I try to see sometimes, why there is a gap, because we talk about automation, all its benefits, how wonderful it is and so forth. And yet
Yeah.
there is sometimes a very real resistance, to your point about
Yeah.
innovation.
Yeah.
And what do you think drives that?
Um, I think lack of resources probably is the number one, because obviously, if you're say a biotech startup company, you're already investing in innovation. You've probably already got something that's very, cutting edge and innovative. So that's, biotech companies are, they're probably going to be quite, you know, sort of half the mark when it comes to, automating a process. And whereas I think probably maybe in more traditional sort of red brick universities, they would probably already got all their protocols and SOPs in place, right? And it's probably already it's been working for them for so many years. They probably just don't want to deviate from that because I think, oh well, why should we? We've always, and I suppose it comes down to, what your outputs are. And for a lot of academics, their outputs are, grants and publications. And if you can get your grant and publication, using using students, and don't forget there is you do have quite a large student workforce, right? So you've got your undergrad students, you've got your master's students, you've got your PhD students. So probably the postdocs are probably the people who are going to be most open to lab automation, and they're probably going to be like, well, why are we wasting our time doing this? Because we'd much rather just get the data and start analyzing the data and writing papers, getting our publications. But then you have like this huge student workforce that are all there on placement, so they need to be in a laboratory and they need to gain lab experience. So probably one of the USPs for lab automation is you are eliminating those repetitive menial tasks, but probably in academia those repetitive menial tasks go to the students, right?
Yeah.
So they probably, for a professor or an academic, they might not want to invest in lab automation if they already have sort of like free labor to actually do those jobs that people otherwise in industry wouldn't want to do.
Yeah, but I mean, do you think then that's I mean, because I hear you talk now, I think, okay, that's really limiting though, because these are talented people. They
Yeah,
love science,
exactly.
they get
Yeah,
into
yeah,
it for,
yeah,
for a whole bunch of other reasons, not to sit and to manually pipette from one field
yeah.
to another, so to speak.
Yeah, I mean,
So
some of the jobs as well. Like, I mean, I remember, when I was at the University of Manchester, and especially final year PhD students, because at that time, but when you get to your final year, you're actually at that stage where you know exactly you've done all the troubleshooting, you've made all
yeah.
the mistakes, and you know exactly what you need to do, and you just need to get the data. You need to get an N of 3. It needs to be statistically significant. So you're repeating your experiments again and again and again, because you want to be able to write up in your thesis. And so there was students who were doing qPCR, and they were doing 96 well plates, 384 well plates, and they were doing it all manually by hand. And it was guaranteed within a couple of months they all had RSI and they were all off sick, which is again this is an occupational hazard. And again, this is another one of the is one of the advantages for having lab automation. But I don't think having could have quite easily have had a liquid handler do some of those tasks. But again, it's just not, if the academics aren't thinking along those lines, they don't, it's almost doing a cost, it's doing like a cost benefit really, and presenting it to them to say, this would be the benefit of having lab automation.
Yeah, and so actually that was, you're building onto my next question then, so how do we, maybe even as an industry or even as a Tiger Team, lab consultancy,
Yeah,
so forth, how do you then overcome such resistance then? I mean, because you're going in, you're chatting with them about the manual workflows, you're explaining to them, this
exactly.
would
Yeah,
be better
yeah.
if it was automated, and these are the reasons why, and so on and so forth.
Yeah, I mean, obviously, obviously, the clients that come to me are already thinking about lab automation, so I don't need
Right.
to convince them. But, um, I think it's kind of almost like demystifying lab automation, because obviously, if you're new to lab automation, it can be quite scary, right?
Yeah.
Especially if you don't know how to program it, you don't know where your plates are going to go, you don't know what the software is going to be like. If you've got no experience of using automation. And I always think, having a sort of just a small benchtop liquid handler, I always think that's really nice. I think, rather than going for this huge, big, massive work cell that has so many components that, it's quite complicated, and is, to integrate it as well is quite a lot. I think just having, small benchtop liquid handlers is, I think, one of the nicest things to go for, really. And, just it's quite easy as well to see the benefits of that in quite a short period of time. So yeah, having small benchtop liquid handlers that are quite easy to program, quite easy to use,
Yeah.
and having someone to come on site and set them up for you, and show you how to use that is, I think, is probably I think that's quite a nice step forward, really.
But do you think, let's say, as an industry, there's something that we could be doing more? Yeah, not really from like an individual company perspective, but as an industry.
Yeah, to almost like to raise awareness or like to promote lab automation in general. I think it's almost having those, it's having people who are quite experienced in using liquid handlers actually being on site and actually doing training sessions and doing workshops and doing demos. I think that's like the easiest. I think that's quite nice because otherwise it's, if you're in not all laboratories are like this. It depends on the institution, but if you're in a laboratory where science is pretty much done on a shoestring, to them have, a workshop where lots of different suppliers and companies come in and show you and actually do demos of their equipment, I think that's actually a really nice way to almost break the ice and sort of demystify and make it easier, more accessible, I think, for scientists, and especially putting it in a way where you're actually taking something that they're doing day to day in the lab. So,
Yeah.
just showing someone, just showing a liquid handler saying, oh my God, with different colored liquids, which I think is still quite nice, but, just showing different colored liquids, aspirating and dispensing, doesn't really, I don't think it really sells it that much to a scientist. You'd kind of want to see your protocol. So whatever you're working on in the lab, if you saw that actually programmed and set up, and someone actually doing that for you using a liquid handler, I think that's actually, I think that'd actually be really, really beneficial.
Yeah, I mean, I actually also think that, I mean, there's many things I think we can do as an industry, but even just, I think if a scientist were to network more with other scientists.
Yeah, well, this is a massive
That's a
issue.
big
Collaborate,
takeaway.
like, yeah,
Yeah.
scientific collaborations is so hard. Sometimes within, within one university or within one organization, even building those relationships is quite difficult. But, like, you know, forging collaborations between industries and between different organizations is so difficult. And it comes all down to, intellectual property and contracts and things like that. It's actually really, really hard. Yeah, I
Yes.
think that, I mean, that's an issue, like, generally speaking.
Right. Okay. So, look, my next question, I don't know if you're going to be able to answer. I don't know even if I can, but so we
Yeah.
talked about, resistance to automation, but at the same time, I mean, there are labs that are open to automation.
Yeah.
Um, so for the labs that you've come across that are open to automation, are there any, I'm trying to think how to ask this question really, but are there any particular characteristics of labs that are open to innovation that, you almost know beforehand, okay, these guys, they're open to innovation. I don't know, maybe it's the application that they're working on, maybe it's the number of samples that they're going through.
Yeah. Yeah, I'm just trying to think.
I'm
That's a
not
really
sure.
interesting question because I'm trying to think about all the different labs that I've been to now. Because I would say hospital labs can be, even though you'd think hospitals might be quite sort of risk averse, but actually, if because there's a thing called like we have something called like a pathology network, so it's
Yeah.
all the laboratories across the whole of the UK, and there is sort of and we are building on this, but there is cross communication between those laboratories. So if one lab does have say if it's in hematology and they have like a blood analyzer and that's fully automated, having one lab, so if you had one NHS pathology lab that had that automated blood analyzer, for example, then I think actually especially when staff move around as well,
Yeah.
um, it promotes that automation because then they'll be like, oh, well, actually that's being used in such a hospital and, they're processing thousands of blood samples a day. So I actually think almost um, having a reputable organization being using that one particular piece of automation and then having almost like word of mouth,
Yeah.
I think it spreads, if people are talking about it, then that almost helps with that sort of innovation and introducing innovation into somewhere like the NHS where people can be quite sort of risk averse, especially when it comes to clinical samples, because that's a whole level of, sort of patient care and quality that's involved in that.
Yeah. Well, I mean, anything that entails change, I guess, people do become particularly resistant at times.
Yeah. Yeah. I feel like any organization that has maybe a business development manager and maybe sort of an innovation type manager or anything to do with or an innovation lead. I'd say they are probably quite good organizations. They'd be much more open to change.
Yeah.
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 Interesting. It's just something to think about, I guess.
You're looking for a secret formula, aren't
No,
you?
I mean, there isn't really. I'm just curious. We always talk usually more about resistance than we do the ones that are open to automation.
Well,
So,
it's the selling points as well of your particular equipment, and as well, sort of, if you can show that you have, if people have published as well, so having publications to support that piece of equipment, so you can say, oh, well, we ran, 2 million COVID samples on this, and it's fully valid, we fully validated
yeah,
this piece of equipment using, 2 million, clinical samples, and these are the results we've got. And if the scientists or the academics can, and or the clinicians can publish that, and they've also then cited your particular piece of equipment then, or acknowledged you in that paper, I think that's also really good, because then you can then take that to the next customer and say, well, look, we used it on this project in this hospital or in this laboratory, and this is, it's published, and it's been through the peer review process, so
yeah,
it holds quite a lot of weight. And I think that's always very good. Or poster presentations as well. So if you have students or postdoctoral like research associates at a university, if they have used or demoed or used your piece of equipment to then gather a body of data which they've then presented at a conference or a symposium or some kind of congressional talk, that poster is that's a published document, and then that would also lend weight to your piece of automation.
yeah. Okay, so final question then.
Yeah.
Yeah. If you think about, automated solutions and their implementation,
Yeah.
for it to be successful, what ingredients need to be there, so to speak?
Oh, it's multi-collaborative, I think. So having a good design team, so having people involved at the design stage to say, well, okay, you've got the scientists, you've got your mechanical design engineers, you've got your electrical engineers, so you've got everyone involved who needs to be involved in actually designing that automation. So having that at the very onset, really, because I think it's very difficult later on to sort of retrofit. So having people involved at the very beginning, so having all the experts consulted at the very beginning part of that process. So then you're not really missed anything off. I mean, quality assurance and health and safety are also very important.
Yeah,
So if you know that liquid handler, that piece of lab automation is then going to go into a hospital laboratory, then you want to make sure that the quality lead and the health and safety lead are aware that this is coming, because they would also, everyone would put, everyone's going to sort of make their own comments and put their own they're going to look at it and make their own assessment, right? So you would want everyone involved to then say, okay, well, we're going to be dealing with very hazardous clinical samples, so where on this liquid handler and where in this automation is that sample, where is it going to go? So you'd want to track that sample from the beginning to the end. So they might look at it and say, okay, right, well, how it's set out, how it's laid out right now is not going to work. Where is that sample going to go? So having things like that, so having health and safety and quality involved, like a quality lead involved, I think is really important. And I think it's hard later on, because you don't want something dumped in your lab that doesn't work, right? That would be
really not. No.
believe you me, you don't want that to happen. So you kind of want those people involved at the beginning, because ultimately someone has to, as a supplier, you're, going to deliver a piece of equipment, but ultimately, someone in this laboratory, and there's going to be some kind of clinical oversight. There'll either be an academic professor or a clinician or a doctor. Someone will be taking ultimate responsibility and accountability for the quality of those results and the results that are going out to patients, for example. So that person should, I think, should be involved in the project from the very beginning, so that, whatever their concerns are, they voice them, and then that's actually incorporated into the design and the development of that project. Because you don't, last thing you want to do is put something, put a piece of lab automation in someone's lab, and then the head of health and safety or the head of quality or the clinician or the doctor turns around and said, well, actually, I'm not happy with the way those clinical samples are being treated or disposed of.
Yeah.
So then that kind of, that would be a complete waste of that entire project. So I think having them involved in the very beginning, and then working with the engineers to say, oh, actually, is this possible? This is really important for us, in terms of processing these clinical samples. And this is how we would process it manually. How can we make sure that's fully integrated and translated into the lab automation? Because we obviously don't want to, we don't want to design something that's not fit for purpose. And I think that's really important, that it is fit for purpose.
Yeah, no, those are really excellent points. Saba, I said at the very beginning that I was delighted to have you on, and you've been an absolute delight. So I really want to say just thank you very much for your time. I really appreciate it, and thanks for all
it's always lovely
well.
talking to you, Alex.
And it's at least I can say now also I know somebody who tested the saliva of Will Smith also. Yeah. Also another claim to fame that I have now as well.
I had a piece of his DNA.
Thank you.
Thank you so much, Alex.